Hello everyone, I hope you're all doing great. Um, just want to let you know I began reading a new book. It's called Lifespan, and I just wanted to give a brief summary of what I've started to read, and it's actually um, pretty cool. So um, essentially, it turns out that there's different hallmarks of aging, and these include genome instability, telomere attrition. You guys probably already heard of all those. Changes to the epigenome, loss of protein maintenance, dysregulation of nutrient sensitivity, mitochondrial dysfunctions, senescence or like zombie cell accumulation in our bodies, loss of stem cells, right, and a change in the intercellular communication between our cells. So it turns out, and David Sinclair points it out in his book, there's actually a single reason for all of this, right? So there's a singular reason, and it's actually the loss of information. And so, not specifically genetic information, like originally proposed by Lizard, which was believed that it's just because of the DNA mutates. Well, it turns out that our DNA is actually stored in digital information in base 4, and it can be recopied. It's a very reliable way to copy and store information. It's like kind of like a DVD, right, or our computer storage, and so we can easily recover it if it's scratched. Our epigenome, however, is analog, and so there's many ways to store it, and it's good because that allows us to respond to changes in our environment, right? It's much more responsive because it can be in so many different states, right? Analog. The problem being is we cannot replace it, we cannot copy it, so there's a loss of information over time. So if we can only remove the scratches and polish it, that will allow us to extend our lifespans. And so essentially what happens is when a fertilized egg starts, it gives rise to 26 billion cells in our body. But what happens over time with epigenetics or changes in epigenetics causes a loss in the cell identity. And that cell identity means that a heart cell is now going to act like a skin cell. And so that's what leads to organ failure, disease, and death, right? Because the cells don't act the way they're supposed to do. There's this loss of information because the epigenome, which gives the cell its identity, over time is not working as well. And so actually this is exactly how it happens, and we have genes which enable us to have this survival circuit. They're called longevity genes, and specifically they're called sirtuins, and these sirtuins are named after the sir2 gene, which was discovered in yeast, but humans have 7 of them, in fact. So 1, 2, 3, 4, 5, 6, and 7. So mammals have actually 7 of these sirtuins genes. But for them to work, they require a molecule called NAD. And so you get disease actually if you have a low amount of these sirtuins and NAD, and you age faster. And so they're very good for many things, these longevity genes. They reduce inflammation, they allow you to kind of to kind of take it easy when there's stress because you don't want to replicate when DNA repairs. They allow DNA repair to occur. They boost your mitochondria, exercise endurance, boost your memory, help you stay thin. They're actually also called the skinny gene because they help you stay thin regardless of how much you eat. And they increase exercise endurance. So they'll do a bunch of things. They're good for your health, fitness, and for survival. And so the question is, how can we activate those genes? Well, there's actually 2 more. There's also the mTOR, which is regulated by nutrients, and it can also decrease inflammation that's caused by senescent cells, and so it can cause DNA repair, and also it can digest all proteins. So this is very important because if the mTOR pathway is inhibited, then you reuse the old components and you kind of like hunker down and maintain your energy, which is a good thing. Then the last gene is the AMPK, which responds to a decreased energy, just like sirtuins and mTOR. So the question is how to activate those genes. Well, it turns out that acute stress can do just that, and these defenses are activated due to body stresses, and these includes certain types of exercise, intermittent fasting, having a low protein diet and calorie restriction, as well as exposure to hot and cold temperature. We call this hormesis. Acute stresses can actually do a lot of benefits in the long run. And so you can actually also mimic these above with pills like resveratrol and others, which are going to be actually on the market soon, which actually mimic these effects without having to do these acute stresses, without having to undergo intermittent fasting, without having to go on a low protein calorie restriction diet, without having to expose yourself to very cold or hot temperatures, etc. Just by taking pills, you're able to do just